students, welcome to RECTV. This is Kalyan and I am the faculty of Mathematics and Physics. In this video especially we are going to do the proofs based on Thales theorem. Okay, geometry. Okay, of geometry session.
Please subscribe and don't forget to click the bell icon for the more updates.
So what is Thales theorem? As you know that when you have given a triangle and reminding you what is a Thales theorem. Okay, ABC is a triangle. When a line drawn parallel to one of the sides which is intersecting at some other 2 points on the two sides, that will divide remaining two sides in equal ratio. That is what your basic proportionality theorem or Thales theorem, right? So here AD by DB equal to AE by EC. That's going to be your basic proportionality theorem. So now based on this we are going to do the theorem. So now here we have given what is given in the given figure EF parallel to DC parallel to AB. What is EF and DC and AB? This is AB, this is EF, this is DC. These three are given parallel as shown in the figure. And we are asked to prove what? AE by ED equal to BF by FC. AE by ED equal to BF by FC, that we need to show. First of all, take the given condition. This is one EF parallel to DC parallel to AB. Now, actually you need to identify what the type of figure it is. This is trapezium, right? Because here these two sides are parallel sides and these two are non-parallel sides. So a quadrilateral which consists of a pair of opposite sides, a pair of opposite parallel sides and a pair of opposite non-parallel sides, that is called a trapezium. So given figure is trapezium. That is the first thing you need to decide. Here we are studying about basic proportionality theorem which is related to triangles. But we have given something here to prove related to what? Trapezium. Is it possible? No. So then we need to do something extra construction in this and we need to make it a triangle and then we need to apply the basic proportionality theorem, that is Thales theorem, right? So we need to do some extension or something else and we need to get the triangle. Let us do it first. So let us extend DA like this. Okay, so what we did, for our convenience, we produced DA and CB which are meeting at what? P. Which are meeting at a point, which are intersecting at a point P. Now, I think you might have observed that we obtained triangles in that. So now it is possible to apply Thales theorem because we obtained a triangle. Now let us choose, we'll choose two triangles in this. First of all, we'll take this triangle. Which triangle here? Triangle P. This is P. Okay, let me write here with white chalk is PEF. Okay, let me choose here triangle PEF. So I am writing here proof. Okay. Okay, just see. In triangle. Okay, PEF. Okay, in triangle PEF. Okay, if you apply the Thales theorem. Okay, what is Thales theorem? See, if you apply PEF, just see, I'm drawing here separately. This is PEF. Here AB is one of the line which is parallel to EF or not? AB is a line which is parallel to EF as we see in this figure. So can we apply here Thales theorem or not? Exactly. According to Thales theorem, we can apply the rule, the proportionality rule. What is that proportionality? PA by AE. Okay. PA by AE equal to PB by BF. PB by BF. Okay. For my convenience, I am going to add 1 on both sides. As I said you before classes that if you make the same changes on both sides of equality sign, it remains constant. It remains unchanged. Okay. So we can add both sides 1. Okay, PA by AE plus 1. So same one we have added on, we will add on other part also, that is PB by BF plus 1, right? Now if you take LCM on both sides, what will happen? PA plus AE by AE equal to PB plus BF by BF. Now tell me, PA plus AE, what does it gives? PA plus AE, what it is? PE or not? Exactly. We can write here PE. So PE, okay, by AE equal to PB plus BF. PB plus BF. What is that? PF equivalent to PF. PF by BF. Okay, so we obtained some proportionality relation over here. Okay, let us put it aside. Okay, now take another triangle, this bigger triangle in this. What is that bigger triangle? In triangle, let me write here, in triangle PDC. In triangle PDC. Okay, PDC. We can consider again PDC if you take PDC like this. Now in the absence of AB, don't consider here AB, only consider EF. So like this EF is there, right? Now we are not considering AB. In absence of AB, okay, EF is only there. We are observing this line only. So tell me, is these two lines are parallel or not? Yes. So this is a line drawn parallel to DC. That means this is a line drawn parallel to one of the side of the triangle. So definitely we can apply Thales theorem. Again, what is the result of Thales theorem? You can apply PE by ED. PE by ED equal to what? PF by FC. PE by ED equal to PF by FC. Let us suppose this is another relation. Let this relation be 2 and this relation be 1. Okay, I think you might have got this. Okay, I took two triangles. I have chosen two triangles out of this bigger figure and I applied Thales theorem to both of them. Now what did you obtain? So see here, this is one of the relation and this is another relation. Now do one thing here, divide 2 with 1. Divide the relation 1 with 2, divide the relation 2. Relation 1 with, so divide the relation 1 with the relation 2. What happens? So 1 divided by 2. So what happens here? P by AE divided by, what is LHS part over here? PE by ED equal to, again, what is RHS part here? PF by BF. PF by BF divided by, okay, what is RHS part over here? PF by FC. Right? Like this we have divided. Okay, what we did here, we obtained two proportionality relations, okay, depending on the basic proportionality theorem obtained from the triangles in this figure. Okay, and we are dividing relation 1 with relation 2. So here relation 1 LHS by relation 2 LHS equal to relation 1 RHS by relation 2 RHS. We divided like this. Obviously you know that here this denominator parts will be inverted over here. So then how can we write it? here PE by AE into ED by PE. ED by PE. Now similarly here also we can write it like see this here, PF by BF as it is inverted, FC by PF. Okay, now I think so same terms we obtained in numerator and denominators are of both LHS and RHS. So here PE can be cancelled in numerator and denominator part, and here also PF can be cancelled in both numerator and denominator part, and what are left over, just write it down, ED by AE equal to FC by BF. I think we obtained our given relation. Okay, just tell me here ED by AE equal to FC by BF. If you invert the expressions of both sides, then also equation remains same or not? Exactly. So when ED by AE equal to FC by BF, then in reverse what can you say? Then AE by ED AE by ED equal to BF by FC. So I think this is what your required relation. So we proved it or not? Exactly, we proved it. So we took a help of extended line segments over here and we made it as a triangle, and then after by the help of triangle we applied the basic proportionality theorem to that, and we could solve it like this. Understand? And it's also one of the important property for trapezium. See, it also looks like, see, whenever ABCD is a trapezium given, when you draw a line parallel to the parallel sides of the trapezium, okay, that will divide non-parallel sides in equal ratio. Is that right or not? See here, AE by ED equal to BF by FC. That means what? This line which is drawn parallel to the parallel sides will divide these non-parallel sides in the equal ratio. Got it or not? So it is almost similar to basic proportionality theorem or not? But that means what we did here, we obtained one relation, we obtained one proportionality relation using the basic proportionality theorem of triangles for trapezium also. Understood or not? For trapezium also we obtained one proportionality relation using basic proportionality theorem of triangles. Understood? I think you might have understood this part. So like this you need to analyze this. Actually you might have learned that how to prove the basic proportionality theorem. But I am telling you, you can apply the same basic proportionality theorem to prove some other theorems also. These are like some other proofs, okay, which is connected to what? Trapezium also. Like this we can do. Understand? So this is what about this proof.
Please subscribe and don't forget to click the bell icon for the more updates.